Hello my dear friends and welcome to Neura Skills. Please, in this channel we are going to make neuroscience simple, practical and actually enjoyable to learn. We are a team of EEG experts, researchers and educators who develop courses to help you build real analysis skills for real work. In this video I'm going to show you everything about the plot function in MNE. But before that, plot is one of those beautiful English words that has several completely different meanings. And all of these meanings come from a long history. My friends, plot originally meant a small piece of land, yes, in Old English, and a few centuries later the word started to mean a ground plan or map, which is already a lot closer to data visualization today. And finally, by the 17th century, plot also meant the storyline of a book or movie. So today when we say we want to plot EEG data, we are actually using a word that has traveled through land maps, secret plans, and storytelling. So please, in a way, an EEG plot is a story. It is a story of brain activity over time. So in this video, I'm going to start simple by loading a EEG data and opening the interactive MNE browser. And from there, I will explore how to move left and right through your recording, how to add annotations, how to mark bad channels, and how to customize the visualization using the most important arguments of the raw.plot function. So these arguments include duration, peaks, number of channels, live filtering, and some other interesting features. So by the end of this session, you will know exactly how to navigate, customize, and interpret your EEG signals by using MNE's interactive viewer. So here, please consider that we have imported the necessary libraries and also enabled the interactive plotting backend, which we use Qt5 AGG. This is required for scrolling and annotation features. And after that, we specified the file path to our simple EDF file. And then we used io.readRawEDF with preload equals to true, which means that the data will be loaded into the memory. So here, when I run this cell, we can see that MNE has successfully detected the EDF format, and it read the metadata, created the channel information structure, and started loading the full recording. And it means that our raw EEG file is now ready for visualization and interactive exploration. Okay, let's try the simplest case, which is typing raw.plot without any input arguments and see what it gives us. My friends, if you use this plot without any parentheses, no plot window will be shown. But general information about the signal will appear. So for example, how many channels we have and how many seconds the recording is. So here we can see that we have 23 channels. We have this number of data points and this many seconds, which is obviously a lot. The reason is that this EEG file that I opened is from an overnight sleep recording and it contains 8 hours of data. But if we run the same function with parentheses, I mean without any arguments, everything will be in the default setting and the plot will be displayed for us. So here you can see that the channel names are presented on the left side of the screen, and it's clear that we have both EEG signals, and here we have muscle signals, for example, EMG1 minus EMG2. These are muscle channels. And at the top, we have also electrodes for the eyes. For example, we have ROC, which is right oculogram, and LOC, which is left oculogram. And another thing is that we have a horizontal scroll bar for moving to the right and to the left, and a vertical scroll bar for moving up and down. So if I press left and right keys, we can go through the signal in time, and with the vertical scroll up and down, we can actually see the channels that are lower in the list. So for example, here you can see that ECG or EKG channel wasn't visible before, but it is now visible here. Please, if you press home or end keys, the visible time window becomes smaller or larger. By default, this visible window is 10 seconds. As you can see, when I open again the signal, you can see the duration is 10 seconds. You can see it's from 0 to 10. And when I press the end key, it increases the window by about 2.5 seconds. And when I press home, the same amount is reduced. So let me mention here that we can also change this default 10 second duration window using the duration function in the plot. So let's go back to the code. Here, if I set duration equals 50 and press Ctrl Enter, we can now see that the default duration becomes 50 seconds. If I change it to 100, the duration will be 100 seconds. And pressing the right arrow keys move the view forward by 25 seconds because the right arrow keys shift the signal by 25% of duration value. Interesting, right? Now let's go back to the default 10 second duration here and look at our signal again. Please, my friends, if I use the plus and minus keys on the keyboard, we can increase or decrease the visual amplitude range of the signal. Another point is that right now we can see all channels at the same time, and we need to scroll down using this vertical scroller. But also we can change the number of visible channels using the page up and page down. So for example, if I press page up and page down, I can decrease and increase the number of visible channels here. So these two keys, page up and page down, let us show more or fewer channels at once. So let's go back to the code and see if we can set this from the beginning. Yes, we can do that. And there's an argument called n_channels. So by default, this argument is set to 20. If I set it, for example, to 25, we can see all channels here, and we can see all the channels in our signal from the start. Or let us, for example, set it to 10 and plot the signal again. We can see what happens. That's great. Another useful thing we can do with the plot function in MNE is apply filtering on line and immediately see how the signal changes. For example, suppose I want to filter the signal between 5 and 4 Hertz. So I can easily do this by using the low pass and high pass arguments. So here I just write, for example, low pass to be 5 and high pass to be 40, and we can see the effect right away. This is the signal between 5 and 40 Hertz. Let's revert back the number of channels to 20 here. My friends, another argument that we can use is the title parameter. So we can give a name that will appear at the top of the plot window. If I type title equals sleep EEG, then I can see this title as well. Let me remove the online filter here and see the title, which is presented here at the top of the screen, top left of the screen. Many times, my friends, we don't want to display all the channels at once, and we need only some of them, some specific channels. So in that case, we use the pick argument in the plot function. So for example, let's say I want to show only the channels F4, frontal channels, and the channel F8, for example. So the only thing that I have to do is to use the picks argument and then indicate the name of the channels. So here in my dataset, F4 channel name is F4 minus A1, and the F8 channel is also F8 minus A2. And then finally, when I press Ctrl Enter, it is F1 F8A1, if I press Ctrl Enter, I can see only those channels that I've selected. So as you can see, I can scroll and see these two frontal channels in the plot. Please, my friends, there's another thing we can access inside the plot function, and that is the theme argument. This argument actually let us change the appearance of the plot window. For example, we can switch the theme to dark or light. So for example, if I use dark, I can see the plot in the dark theme. But my friends, if you don't see such result, it is mostly because the theme option only works with the Qt backend when the Qt backend is actually activated. So right now we are using the default backend, which is Qt5, but if you want to see the theme and its difference with the light theme, you should use another backend. So in other words, the theme argument does nothing unless we switch the browser engine to Qt. And Qt is a modern graphical user interface, and it is actually a system that allows Python programs to open real windows, buttons, sliders, menus, and interactive tools. It's a little bit more advanced than the basic Matplotlib viewer. And when MNE uses the Qt backend, it can give you a faster and more professional EEG browser. And this is the same thing that many desktop apps use, for example, and they let you to do everything feel more responsive and more powerful. And the important point is that MNE's dark and light theme are built into this Qt browser. And that's why your theme, if you use this theme without using the following codes, it might not work because we are still using the Matplotlib backend. So how do we switch to Qt? The first thing is that you need to install the Qt browser, which is an engine for MNE. It doesn't come by default, so you should type pip install MNE Qt browser. And then after installation, you usually restart your Jupyter notebook and then activate the Qt backend with this command, which is mne.viz set browser backend Qt. If you want the dark theme to work, you should also install pip install qdarkstyle dark detect. And now when you run this code, you will actually see the difference in visualization. You will immediately see the dark mode, which is applied here. It is good for night vision, and the whole interface switches to modern Qt window, which has scrolling, a more smoother scrolling. We have cleaner visuals. All right, let's check this viz.set browser backend and see if they have any difference with our previous Matplotlib. You see there's one major difference between these two plots, which is z-score mode, and you can see how it works later in the video. Now let's plot the raw data, the full raw data right now, and see what we have here in the Qt version of the visualization. So here we have a menu which has three options: empty, channels, z-score, visible. You can make it visible or not visible. This is actually, my friends, about the summary of the signal, which is represented here. So if I choose empty, there will be no summary of the data here. If I choose channels, I will see the EEG channels, an overall view of the EEG channels. This is actually a smaller version of the signal here. If I choose z-score, I will see z-score values here. This is an interesting part of the Qt backend. So what does it mean? When you use z-score, you're actually seeing a normalized version of the EEG. So each channel here is scaled by its mean and standard deviation. And this is what makes all channels comparable and helps you, for example, spot artifacts or noisy channels. So for example, cleaning, scoring, or just exploring, you can switch between these three types of views here. If I click on this, it will be removed totally from the button. So let's go back to visible and see what we have in Z-score mode. In Z-score mode, my friends, the overview bar is not showing the EEG waveforms itself. So it is a statistical map of how much the signal in each segment deviates from what is normal for that channel. And most of the bar appears blue here. Why? Because blue represents values close to the mean. And let's say, for example, parts of the signal that look typical or stable for the channel are in blue. And there are also some periods, for example, here that you can see the color is red. And these red patches actually show deviant from the mean. So my friends, a red area means the Z-score is high, and it means that the signal is far from its average. So these red sections of the EEG indicate artifacts, for example, muscle bursts, electrode pops, strong eye movements, or other abnormal fluctuations. So because the overview bar is extremely compressed in time and amplitude, it is not meant to be readable as EEG, and instead it acts like a heat map that highlights where unusual events occur. So the reason most of the bar is blue is that most of the recording is normal, and the red spots might indicate that there is some abnormality in the data. And it lets you quickly navigate long recordings and jump straight to the problematic segment. My friends, at the top of the Qt browser window, we also have a row of tools that make exploring the EEG much easier. These icons give us quick access to useful actions without typing anything in the code. So for example, when I click the pencil button here, I will enter the annotation mode. And this annotation mode lets you mark segments of the EEG directly on the plot. So when the annotation mode is activated, a new toolbar appears on the top and under the main icons here. And you can choose a description label. For example, this is a sleep EEG, so I can type, for example, a spindle, press OK. And I can mark spindles in my EEG data. On the other hand, I can add another description, which is artifacts, for example. Click OK and select those parts that are considered to be artifacts. And you can see the labels here are represented at the bottom. So when you click and drag on the signal, you can mark the time interval you want. So with these buttons in the annotation mode, you can remove description, edit descriptions that you have. So for example, you can change artifact to something else. You can select visible. You can just select which artifacts or which segments of the data to be visible. If I just remove this artifact and click on OK, I only see those spindles, and I can just change this visible to all labels and click OK. So my friends, this mode is extremely useful for example, for slip scoring, artifact marking, or labeling any event you need to track. Once you finish annotating, you can exit annotation mode by clicking the pencil button again, and all annotations are stored in the raw object for later processing. Another thing you might expect in the MNE browser is that when you left click on a name of the channel, it should show the sensor's physical location on the scalp. But in this EDF file, nothing happens when I just left click. Why is that? Because the dataset does not contain any electrode position information. There's no 3D coordinates and no digitization points. So because of that, MNE has no way to know where each electrode actually was on the head. So the location view cannot open. So to make this feature work, we need to assign a standard montage, such as the 1020 system. And we do this by setting the montage of the raw data. And once the montage is applied, when you click on a channel, it will correctly show its estimated position. So here you can see that we have the CH names. When I press Ctrl Enter, I can see their channel names, the channel names that are here in my data set. I can set the channel types to different types. So for example, ROC and LOC are both EOG, a kilogram, and EMG is a type of EMG, EKG is ECG. So I set the channel types here. All the remaining channels will be EEG. So let's run this code. So here you can see we have 19 EEG channels. When I click, I can see the names. I have 2 EOG channels, ROC and LOC. I have 1 ECG, which is ECG-R minus ECG-L, left and right. And I also have 1 EMG channel. So because the names in standard 1020 are actually FZ, not, for example, FZ minus A1 or F4 minus A1, I just here added a code that removes those minuses. You do not need to do this for your dataset. This is only applicable for this type of dataset. And then I can just use the montage function here, set montage function, with using MNE channels make a standard montage, and our standard montage is 1020. And then I will set the montage to raw data. And then when I use raw.plot, and I can see the names are just in a standard format. And when I left click on the name of a channel, I can see its position in the standard 1020 system format. So for example, here I left click on CZ. This is the middle electrode. One more interesting thing is that when I'm in the interactive plot and when I press B, I can see something interesting, which is a butterfly mode. And butterfly mode is a special visualization in MNE, and all EEG channels are plotted on top of each other. So here we see that all 19 EEG channels are plotted upon each other. The 2 EOG channels are plotted upon each other here. So if I, for example, increase the amplitude, I can see there is 19 channels plotted upon each other. So what does it mean? How can it help us? Well, at first it looks a bit chaotic because every channel overlaps, but it is incredibly useful when you want to see the overall shape and consistency of your EEG data. For example, if you have 19 EEG channels and one of them is noisy, so in the normal static view, you may need to scroll down to find it. But in butterfly mode, that channel will immediately stand out as a waveform that doesn't match the others. And it's also great for seeing global brain rhythms. So if a participant, for example, has strong alpha activity at, for example, 10 Hertz, all the channels will show the same gentle oscillation, and the butterfly plot lets you see that pattern at a glance. So even though it looks like a swarm of colorful lines or black lines, this mode gives you a way to detect outliers and check data quality and understand the global structure of the EEG quality. Alright, my friends, that brings us to the end of this session. We explored almost everything you need to confidently use the interactive EEG browser in MNE. So we first learned simple navigation and scrolling. We also learned how to change duration, how to select different channels, how to filter on the fly, using themes in the Qt backend, and working with the overview bar and understanding advanced options like, for example, Z-score mode and annotations. These tools, my friends, please, are very powerful, and once you get comfortable with them, you'll be able to move through your EEG recording, mark events, clean artifacts, and prepare your data for analysis with much greater speed and accuracy. Alright, if you enjoyed this tutorial and you want to continue learning EEG analysis step by step, from filtering to epoching to ICA, ERP extraction, time frequency analysis, and real scientific workflows, please, my friends, check out our complete EEG ERP analysis with Python course on Udemy. This is one of our in-depth courses, and thousands of students around the world are already using it to build real research skills. Don't forget to subscribe to Neura Skills channel, leave a comment if you have questions, and share this video with anyone who might benefit. We have many more tutorials coming, so stay tuned, and as always, keep learning and keep exploring your brain ideas, your brain data. Thanks for watching, and I will see you in the next video. Thank you.